All right, so think about graphing a line, and then you're going to graph whether it's above the line or below the line, greater than or less than, and where the two regions intersect is your answer. So the only way I'm going to teach you to solve these is by graphing, all right? Because it is an entire region of points that you're looking at, okay? So you are simply graphing the line and then shading. That's all you're doing to do these. All right, I will say for this one, they gave us a 0.5. I would actually rewrite that little guy to be 1/2 x minus 3 because it's easier to graph because it's rise over run, okay? So I'm going to graph the first one, and I'm going to start at -3 with a slope of 1/2, up 1/2, okay? And that's going to be like that. And then if you look, it says greater than. Y is larger than that. So you look at your Y. My Y is right here, and I'm going to graph everything bigger than that, everything above it. So this would be the graph for that. This would be the shading for this guy. All right? And then I'm going to graph my second one. I'm going to start at +7. My slope is -2, so down 2/1. And you can walk it if you need to, but it's going to look something like that. I'm going to point out one more thing. Oh, that's not very nice. I'm going to point out one more thing about these really quickly. These were both greater than or equal to. All right. And then this is less than. So for this one, my shading would be below my Y on this. So my shading is going to be like here. And your answer is where those two cross over, okay? So where those two cross over, well, that's this wedge right here. Everybody see the wedge that's created?
Yeah. I indeed see.
All right, two things I want to point out. This was or equal to, they both were. If it is or equal to, you have a solid line, all right? Had it been just greater than or just less than, you would have used a dashed line. It's like the open circle and the closed circle on the number line. Open circle is not or equal to, closed circle is equal to. It doesn't include the line if it's just less than, all right? Makes sense? That's the extent of solving inequalities. I do want to point out some special cases. If you look at example 7, you see example 7, you will notice that the two regions never crossed over each other. That is a no solution, right? If one goes one direction and one goes the other and they never cross over, it's no solution because there is no place where the two regions actually cross over each other. All right. So those are your special, that's really the only special case you're going to get on this is maybe it doesn't cross each other. All right.